Hello everybody, welcome back to another video. I hope you're all doing well. In this video, we're going to be taking a look at a question from the IB Chemistry Paper 2 HL from November 2018, time zone 1. And this question is to do with enthalpy change and more particularly calculating enthalpy change using bond enthalpies. Now, a while back, I put up a post on my Instagram where I asked you guys which questions you find difficult. And one of the most common ones was common topics that you guys said was topic one. And I've covered a lot of questions from topic one in many different videos before this. So I think I have closed that chapter for now. And now I'm moving on to another common topic that you guys find difficult, which is topic five. And in topic five, in almost every single exam that I have personally done, I see questions like this. These are the questions, these are the type of questions that I see, and they're usually worth a lot of marks. And they are all to do with bond enthalpies. So let's start taking a look at this question. And before we begin, if you are hearing some weird sounds in the background, that is actually the wind outside my house. It is unusually windy in the area where I live, but hopefully that shouldn't be much of a problem. So this question is asking us, under certain conditions, ethine can be converted to benzene. Determine the standard enthalpy change for this reaction stated using section 11 of the data booklet. Now, there are many different methods to calculate enthalpy change. There are many different methods. In this specific question, they're asking us to use the method to calculate enthalpy change, which tells us in section 11, right? So if you flip to section 11 of your data booklet, you will see that it involves bond enthalpies. They have given us bond enthalpies and average bond enthalpies of different bonds, double bond, triple bond, single bonds. They've given us a table. They've given us a lot of information over here. So we have to use this information to calculate the enthalpy change. And how are we going to do that? The very first thing that I want you to do is I want you to draw out the structure of these molecules, the molecules that are involved in the reaction. So we have the first molecule, which is ethine. So what is ethine? What is ethine's molecular structure? So it looks something like this. You have a carbon, you have a triple bond between a carbon, and then each carbon is attached to one hydrogen. So that's C2H2. And then this is converted into benzene. And we know what benzene is. Benzene is nothing but this. 3, 4, 5. Oops, that's a funny looking benzene there. I had to fit in 6 carbons. Let me make that slightly better. Sorry, that's still weird. I'm not good at drawing. Okay, I know it looks a bit weird, but just deal with it. I think you get the idea of what I'm trying to do over here. This is just a benzene structure, and then you have this dots over here, this intermediate. Now remember, if you are used to seeing benzene like this, we don't use this structure anymore. I have explained it in a previous video. This is Kekulé structure, and with the advancements in recent technology, we have eliminated the structure. It has been debunked, you could say it is incorrect, and we use a modified structure where there are no alternating double bonds like you saw over here. There are no alternating double bonds. Instead, there is an intermediate bond between all the carbon atoms. And this intermediate bond is formed by the delocalization of the pi electrons, which occurs between these. So you could think of these electrons in this delocalized ring over here. These 6 electrons, one is contributed by each carbon atom. These are shared over all the 6 carbon atoms to help maintain stability. And obviously each carbon atom is also bonded to a hydrogen. So this is the molecular structure of our different substances. Now let's get down to calculating the enthalpy change. Now the formula for calculating enthalpy change for this specific method where we use bond enthalpies is the number of bonds broken. So it's bonds broken minus bonds formed. So the enthalpy of, I should put enthalpy of bonds broken minus the enthalpy, this E is enthalpy of bonds formed. And we have the enthalpies given to us in in section 11, and we have the enthalpies of the products, or the bond enthalpies of the products which have also been formed. So everything is given to us. All we have to do now is substitute the value in, and then we should be good to go and solve this question. So let's first focus on the enthalpy of the bonds broken. Let's take a look at this molecule, ethyne. How many bonds are going to be broken in ethyne? Well, for the sake of this question, I'm going to assume that all of these bonds are broken, and that's what you should do as well in the exam. Just assume all of the bonds are broken because you're forming a completely new substance. So in these questions, assume that all of the bonds are broken. So we have a C triple bond, carbon triple bonded to another carbon. What is the enthalpy of this bond? Well, if you look at your data booklet under the section, in section 11, in multiple bonds, you will see the enthalpy of a carbon triple bonded to another carbon as being 839. So this is 839. Then we have the carbon, then this carbon is single bonded to another hydrogen. So the enthalpy of that is 414. And then there's another same carbon single bonded to a hydrogen, this 414. So we have to add all of this, and we have to multiply it by 3, because in the equation, we actually have 3 ethynes, the 3 moles of ethynes. So we have to multiply all of this by 3. Don't forget that that's a very crucial step. And we get the final answer as 5001 kilojoules. So that is the enthalpy required to break 3 moles of ethyne. Now we have calculated the enthalpy of bonds broken. Enthalpy of bonds broken, it's BB. I'm going to keep bonds broken as BB. What about enthalpy of bonds formed? What about enthalpy of bonds formed? What will this be? EBF, enthalpy of bonds formed. Well, let's first calculate the enthalpy of the carbon to carbon bonds. Now, in this question, you cannot assume that the carbon to carbon bonds is a single bond. The carbon to carbon bond in this case is an intermediate. There's a single bond and then there's an intermediate bond. So you have to be very careful. And for that matter, if you look at your data booklet, there is a special carbon to carbon double. It looks like a double bond, but it is not. There's a carbon to carbon intermediate bond, which is displayed under multiple bonds. It specifically says below in brackets in benzene, and that is 507. So this bond that I'm talking about over here, this carbon to carbon bond, where it's an intermediate bond, it's not a double bond, it's an intermediate bond, is 507. It is not as strong as a double bond, but yet it is not as weak as a single bond. So this is 507, and we have 6 of these bonds, right? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So you can turn into 6. And then we also have 6 carbon to hydrogen bonds, right? We have 6 carbon to hydrogen bonds. And as we saw earlier, the enthalpy of a carbon to hydrogen bond is 414. So we do 414 times 6, and we add this 2 together to get the enthalpy of the bonds formed, the enthalpy change of the bonds formed. The enthalpy of bonds formed. And this gives us an answer of 5,526 kilojoules. And this is the enthalpy of bonds formed. And as I showed you earlier in the formula says enthalpy of bonds broken minus enthalpy of bonds formed. So it's to calculate our enthalpy change, we have to subtract the enthalpy of bonds broken, which is 5001, minus the enthalpy of bonds formed, which is 5526, and we get our answer as negative 5200 and we get negative 42. I was looking at something else. My apologies. So we get negative 42 kilojoules. And that is our answer. That is the enthalpy change. Now, all these steps have to be shown in your working. Otherwise, you will not get the marks for this. The examiner needs to see that you know what you're doing. So please show all of these steps. If it helps you, draw this diagram below, but make sure to show all the steps within the box. That is it for this video. Thank you so much for watching. If you have any other questions regarding this concept or any other concept, please feel free to message me on my social media, send me an email or put it down in the comments below, and I'll be more than happy to help you. I'll see you in another video with another question. Take care and goodbye.